class, good day. This time, we are going to talk about geometric sequences. What is a geometric sequence?
A geometric sequence or geometric progression is a sequence of the form a sub 1, a sub 1r, a sub 1r raised to the power of 2, a sub 1r raised to the power of 3, a sub 1r raised to the power of n minus 1, and so on. Where a is the first term, r is a non-zero real number called the common ratio, and the nth term of the sequence is given by a sub n equals a sub 1 r raised to the power of n minus 1. The common ratio r of a geometric sequence can be obtained by dividing any term a sub n, where n is greater to 1, by its preceding term. That is, r equals a sub n over a sub n minus 1. Recall that in an arithmetic sequence, the terms are generated by repeatedly adding the common difference to the first term. In a geometric sequence, the terms are generated by repeatedly multiplying the common ratio to the first term.
Right, we are going to identify if the given sequences are geometric or not. Okay, let's start off with the first sequence. We have negative 1, 6, negative 36, 216. So all we have to do is to look for their ratio. If they have a common ratio, then it is a geometric sequence. So let's start. 6 divided by negative 1 is negative 6. Negative 36 divided by 6 is negative 6. 216 divided by negative 6, negative 36 is negative 6. So as you can see, this sequence has a common ratio which is negative 6. So we can say that this is a geometric sequence. Let's proceed to the second sequence. We have 4, 16, 36, and 64, and so on. So the same process. 16 divided by 4 is 4. 36 divided by 16 is 2.25. 64 divided by 36 is 1.78. So is their quotient or ratio equal? No, they don't have a common ratio, so this is not a geometric sequence. Next, we have negative 1, positive 1, 4, 8, and so on. Positive 1 divided by negative 1 is negative 1. 4 divided by 1 is 4. 8 divided by 4 is 2. Still not a geometric sequence. So always remember that the sequence is a geometric sequence if it has a common ratio. Understood? This time, we are going to determine the first 5 terms of the geometric sequence given the first term, which is equal to 3, and the common ratio, which is 2. So, the first term is 3, so we'll be looking for another 4 terms. Because we are going to determine the first 5 terms. 1, 2, 3, 4, 5. So, for the first term, we have 3. Now, to look for the second term, we are going to multiply the first term by the common ratio. For the third term, we are going to multiply the second term by the common ratio. For the fourth term, we are going to multiply the third term by the common ratio. And for the fifth term, we are going to multiply the fourth term by the common ratio. So the first term is 3, so we have 3 times the common ratio, which is 2. 3 times 2 equals 6. We have 6. Next, the second term is equal to 6 times the common ratio, which is 2. 6 times 2 equals 12. Next, the third term is equal to 12 times the common ratio, 2. 12 times 2 is 24. Alright, next, for the fifth term, the fourth term is equal to 24 times the common ratio, which is 2. 24 times 2 equals 48. So this is now the first 5 terms of the geometric sequence given the first term and the common ratio. Another example, we are going to determine the first 5 terms of the geometric sequence given the first term, which is equal to 12, and the common ratio, which is 1/2. First 5 terms. Alright. So, the first term is equal to 12. For the second term, the same, what we did earlier, until the 5th term. Purely the use of multiplication here. Alright. The first term is equal to 12 times the common ratio, which is 1/2. 12 times 1 is 12, divided by 2 is 6. So we have 6 here, and then 1/2. 6 times 2 equals 6, divided by 2 is 3. So you got 3 here times 1/2. 3 times 1 is 3. Cannot be divided, so we have 3 halves, or 3 over 2. Three times 1 is 3. 2 times 2 is 4. So it's 3/4. So this is now the first 5 terms of the geometric sequence given the first term and their common ratio. 12, 6, 3, 3 over 2, and 3 over 4. Understood, class? This time, I am going to teach you how to look for the n term of a geometric sequence. So we are going to use this formula. The formula is a sub n equals a sub 1 times r raised to the power of n minus 1. So a sub n refers to the term that we are looking for. A sub 1 is of course the first term, and the r is the common ratio. And here is the number of terms. Get it? So let's have our first example. Example number 1. Find the 9th term of the geometric sequence 3, -6, 12, -24, and so on. So we have the first term is equal to 3. Then we are looking for the what? What term? The 9th term. Diba? So that's a sub 9. So let's get the common ratio first. Let's find out the common ratio. -6 divided by 3 is -2. Positive 12 divided by -6 is -2. And -24 divided by positive 12 is -2. So the common ratio is -2. So we are going to use the formula a sub n equals a sub 1 times r n minus times r raised to the power of n minus 1. So we have a sub 9 since we are looking for the 9th term. A sub 1 is equal to 3. The common ratio is -2 raised to the power of n. We have 9 terms. 9 minus 1. That's it. So we have a sub 9 equals 3. -2. 9 minus 1 is 8. So this time, we are going to multiply 2 by itself 8 times. And as you can see, since the exponent is an even number, so the answer will be a positive integer. So let's multiply 8 times. We have 2 times 2 equals 4, times 2 equals 8, times 2 equals 16, times 2 equals 32, times 2 equals 64, times 2 equals 100, 28 times 2 equals 256. So we have 256. A sub 9 equals 3 times 256 is equal to 768. Great. So this is now the 9th term. Understood, class? Another example, we have the 6th term of a geometric sequence consisting of positive integers is 96. And the 10th term is 1536. Find the common ratio, the first term, and the 13th term of the sequence. So there are three things that we are going to look for. The common ratio, the first term, and the 13th term. So, given, we have the 6th term is equal to 96. And the 10th term is equal to 1536. Now to look for the common ratio, this is how we are going to do it. So let's illustrate it first. We have a sub 6. So we are looking for a sub 7 here, a sub 8, a sub 9 until a sub 10. So we are going to use a sub 6 and a sub 10 in order to look for the common ratio. So we are going to assume that a sub 6 will be our first term here. So we're going to use the formula a sub n equals a sub 1 times r raised to the power of n minus 1. So here will be a sub 10. And here our assumed first term a sub 6. R raised to the power of n, how many terms we have? We have 1, 2, 3, 4, 5. So that's 5 minus 1. A sub 10 is equal to 1536. A sub 6 is equal to 96. So our 5 minus 1 is equal to 4. Then divide both by 96. Cancel. 1000, so we have r to the power of 4. 1536 divided by 96 is equal to 16. Ito siya. First quadrant. R equals positive, negative. The fourth root of 16 is equal to 2. Correct. We have 2 times 2 equals 4 times 2 equals 8 times 2 equals 16. Now, r is equal to positive, negative 2. Since it is consisting of positive integers, we are going to choose the positive one. So the common ratio is equal to 2. Now that we have the common ratio, it's easy for us to look for the first term. Now, for the first term, we have a sub n equals a sub 1 times r raised to the power of n minus 1. So, it's a sub 6 equals a sub 1, r raised to the power of n, there are 6 terms, so 6 minus 1. Then we have a sub 6 is equal to 96. Then equals a sub 1, the common ratio is 2. 6 minus 1 is 5. Now we are going to multiply 2 5 times by itself. So that is equal to 32. Then divide both terms by 32. Cancel. So a sub 1 equals 96 divided by 32 is equal to 3. So the first term is 3. Now, for the 13th term, so the same formula we have a sub n equals a sub 1 times r raised to the power of n minus 1. So we are looking for the 13th term, so a sub 13 equals a sub 1, as we all know, it is equal to 3. With the common ratio is 2, then n, the number of terms, we have 13 minus 1. 13 minus 1 is equal to 12. Now, we are going to multiply 12 times by itself. So it is 4096. A sub 13 equals 3 times 4096 is equal to 12,288. So, the 13th term is 12,288.
How to find geometric means? Suppose we are given that P, A, B, C, Q form of a geometric sequence. We say that A, B, and C are the three geometric means between P and Q.
For example, we have insert 3 geometric means between 3 and 243. So we are going to insert 3 geometric means between these two terms. So first, we should look for the common ratio. How? Okay. As we all know, a sub 1 is equal to 3. Then 243 is the fifth term, so it's a sub 5. So we will be looking for R, or the common ratio. So let's use the formula a sub n equals a sub 1 times R raised to the power of n minus 1. A sub n we have a sub 5, which is equal to 243. A sub 1 is 3. Then that's the R. Then how many terms we have? We have 1, 2, 3, 4, 5. So it's 5 here minus 1. So 243 equals 3 times R. 5 minus 1 is equal to 4. And let's divide both by 3. Cancel, cancel. So everybody has 1. R to the power 4 equals 243 divided by 3 is equal to 81. Fourth root. The fourth root of 81 is equal to positive negative 3. So it's either positive 3 or negative 3. Now if it's positive 3, for positive 3, so we'll be looking for the second term, the third term, and the fourth term. So it's the first term, which is 3 times 3. 3 times 3 equals 9. 9 times 3. 9 times 3 equals 27. 27 times 3. 27 times 3 equals 81. So, if R, or the common ratio, is equal to positive 3, then the geometric means are 9, 27, and 81. Now, how about if negative 3? So, we have a sub 2, a sub 3, a sub 4. You have 3 times negative 3. 3 times negative 3 is negative 9. Negative 9 times negative 3 is positive 27. Positive 27 times negative 3 is equal to negative 81. And if you're going to correct, negative 81 times 3 is, times negative 3 is positive 243. So it's either the two. These are the geometric means if R is equal to positive 3, and these are the geometric means if R is equal to negative 3. Get it, class? Another example. We are going to insert two geometric means between 729 and 64. So first term is equal to 729 and the fourth term is equal to 64. Now let's look for R. So the formula a sub n equals a sub 1 times R raised to the power of n minus 1. So we'll put here 64. Then the first term is 729. And then we have R times how many terms we have? 1, 2, 3, 4. So that's 4 minus 1. We have 64 equals 729 R to the power of 3. So let's divide both by 729. Cancel. We have R cubed equals 64 over 729. Wow! 64 and 729 are both perfect cubes. What a coincidence we have here. Let's look for its cube root. Positive, negative, cube root of such. Cancel. The cube root of 64 is equal to 4. And the cube root of 729 is 9. So R is either positive 4 over 9 or negative 4 over 9. So since ang atong mga given kay positive terms mangkod, so better for us to use the positive common ratio for uniformity. So, okay, class? So we are going to use the positive common ratio. So we have common ratio is equal to 4/9. So we are looking for the second and the third term. So 729, that's the first term, times 4/9. 729 times 4 is 2,916 divided by 9 is equal to 324. Now we have 324 times 4 is 1,296 divided by 9 is 144. So geometric means between 729 and 64 are 324 and 144. Understood, class?
Now, what is a geometric series? As in a arithmetic sequence, we want to find the sum of the first n terms of a geometric sequence. That is, if a sub 1, a sub 1r, a sub 1 r raised to the power of 2, a sub 1 r raised to the power of n minus 2, a sub 1 r raised to the power of n minus 1 are the first n terms of a geometric sequence. We want to find a sub 1 plus a sub 1r plus a sub 1r squared plus a sub 1r raised to the power of n minus 1 plus a sub 1r n raised to the power of 1. This expression is called a geometric series. Let S sub n equals a sub 1 plus a sub 1r plus a sub 1r squared plus a sub 1r raised to the power of n minus 2 plus a sub 1r raised to the power of n minus 1. Multiplying both sides by r, we obtain r S sub n equals a sub 1r plus a sub 1r squared plus a sub 1r raised to the power of n minus 2 plus a sub 1r raised to the power of n minus 1 plus a sub 1r raised to the power of n. Subtracting this equation, we get S sub n minus r. S sub n equals a sub 1 plus a sub 1r minus a sub 1r plus a sub 1r squared minus a sub 1r squared plus plus a sub 1r raised to the power of n minus 1 minus a sub 1r raised to the power of n minus 1 minus a sub 1r raised to the power of n. S sub n minus r, S sub n equals a sub 1 minus a sub 1r raised to the power of n. The quantity of 1 minus r times S sub n equals a sub 1 times the quantity of 1 minus r raised to the power of n. Therefore, if r is not equal to 1, we have S sub n equals a sub 1 times the quantity of 1 minus r raised to the power of 10 over 1 minus r. Example, find the sum of the first 10 terms of the geometric sequence 2, 6, 18, 54, and so on.
So we are going to use the formula S sub n equals a sub 1 times the quantity of 1 minus r sub n over 1 minus r. So it's a sub 10, because we are looking for the sum of the first 10 terms. A sub 1 is equal to 2. We have 1 minus the common ratio, which is 3 raised to the power of 10. Over 1 minus 3. 3 multiplied by itself 10 times is equal to 59,049. 1 minus 3 is negative 2. 1 minus 59,049 is equal to negative 59,048. So we can divide this actually. 2 divided by negative 2 is negative 1. So that's negative 1 times negative 59,048. Negative 1 times negative 59,048 is equal to positive 59,048. So the sum of the first 10 terms of the given geometric sequence 2, 6, 18, 54, and so on is equal to 59,048. That's all for today, class. If you have questions or clarifications, just drop it below in the comment section. I hope that you got something from our discussion. Thank you. Bye for now and God bless.